So I'll be showing how do we sort of create an AI agent, which all of you can also try in case you are prepared with GitHub and VS Code, all those things. Uh, so I think everyone here in the audience would know what is a language model, how does it work, right? Like it works on the basis of calculating or predicting the next token, whichever has the highest probability, that is the one that comes up. So if we look at uh, like open source versus closed source, so in closed source or commercial language models, there are a few leading companies, and Anthropic is one of them. And uh, means they are an offshoot of OpenAI itself, and yeah, very quickly they have become a multi-billion dollar company. So what is it that really distinguishes the models that are coming from Anthropic or Claude with respect to others? So OpenAI was the pioneer in terms of instruction-based fine-tuning, and then RLHF, okay, which is reinforcement learning using human feedback. Uh, Claude, as it claims, they don't have really lot of sort of white papers out in public, but they talk about this terminology called constitutional AI, where the humans are actually embedded in the process of training the language model. So they say that it actually makes the output of the language models more grounded, more like fairer, and sort of harmless. And they like if you want to use any of these Claude models, uh, of course you can go to their website and create an account. It's also available through Bedrock, Google Vertex AI. So if you want to build things and then really want to scale them into production, Google Vertex and AWS Bedrock are two of those services through which you can access these models. Uh, and the main sort of USP or unique selling point for Claude is like that they are able to build these models keeping in mind safety first. So the way it works is whatever output that is really coming out of Claude in terms of the token prediction, there is some self-critic mechanism which is there, and you can see that it is actually in work. Okay, when if you will use uh, any of these, like if you use Claude itself and ask it a question, you will see like it is going back and forth, and it sort of prints a log. Uh, so suppose if we ask it what is MCP server and how does it differ from Claude skills. This is just for showing you like how does the self-critic mechanism actually works. Okay, so well here you can see like something is happening here at the top, like and it's sort of showing its thought process. Though because this was a very simple question, so it didn't have to like do a lot of thinking. It probably just pulled the facts and then used those facts to actually come up with this response. Okay, so let me go back to the slides. And they have come up with a family of language models. And when I started their models, using their models back in 23, while I was with the AWS, like Sonnet 3.5 was generally available. Sonnet 3.6, you had to really get a lot of approvals internally within Amazon to get access to it. But now they have in the last 2 or 2.5 years, things have moved pretty fast. Okay, now they have like 4.5 and 4.6 families, and all those three have become sort of obsolete. And they have a very huge context window. So how many of you are aware like what is context window? Means you can just raise hands. Okay. So for the others who don't know what is context window, so language model produces an output in terms of some token. So for example, here it produced this response, right? And to really create this response, it did some pooling of information. right, which was happening here in these steps. So, and then the question that we asked. So if you add together all the tokens in the question, the information it pulled, and the response that it generated, these three things are in a way consuming its context window. Uh, and like the context window of these models, family Claude 4.5, 4.6 is around 200K. So here we are not even using 1% of that. So whereas if we really look at the earlier family of models, when uh, Claude actually came, okay, like back in बाहर रख दो आप बैग. So when it actually came back in 2023 or something like that, uh, at that time 4096 or 8192 tokens was something considered great, okay. But now we are talking about 200K. And in fact, there are also models which have around a 1 million 1 million token as the context window. I think Llama 4 is one such example. Okay. So now again, like which model do you use? It depends on your own use case. So that's what I've listed here. And if it is sort of doing sort of quick task where not much of thinking is involved, then Haiku series of model is good. If you want to sort of build agents or multi-agents and solve complex problems, for example, creating a complete code repo or I think creating code repo is like a simple example nowadays. Uh, Creating a compiler, okay, C++ compiler, then you should really go for Claude Opus. So in fact, they demonstrated, I have a case study towards the end where they demonstrated that they are able to create a complete uh, 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 sort of uh, compiler. You write a compiler by using Claude Opus. So, so this is like the latest and greatest Claude Opus 4.5, and in terms of its performance on software engineering benchmarks, like it comes at the top, and means it has even solved problems or a task where like the instructions were sort of ambiguous or they were not enough, and uh, if you are but I would say like to solve a simple problem, for example building a RAG agent. RAG, all of you know, right? Retrieval augmented generation. How many of have used RAG at some point of time? Okay, so retrieval augmented generation type of an agent, if you want to create, Opus would be a big overkill. Okay, means you can do that with Sonnet or Haiku very easily, and that's what we are going to do. So yeah, means if you are solving problems which could really be solved using simple machine learning models or ML models, then Haiku is good. Okay, like so for example, if you want to solve a sentiment classification problem uh, with good with sort of low latency, then Haiku is good. Uh, but if you want to build something more rigorous but not really complex, then Sonnet is a good uh, sort of balance there. And if you want to really build things like writing a C++ compiler, things of that nature, then Opus is the way to go. Uh, in fact, nowadays one of the evolving use case of these models is coming out to be like doing literature survey. So if you want to perform literature survey and get an idea in terms of where the research gap really lies, you can go for Claude Opus. So it really shortens your time which you would take in terms of reading hundreds of such paper. Uh, but you'll always have to verify because it has been found that it even ends up creating URLs or DOIs of papers which do not exist. So and this has been caught like even in very good journals. During the peer review, it was found that somebody did the literature survey using Claude, and it manufactured references and it planted them, like, and somebody would think that that is true. So that's where, like, grounding these language models in actual data is important, and that's where the RAG-based approach becomes very handy. So yeah, means if you want to use Claude, then you can use their SDK. Just to install it. If you are in case of Python, if you are using Node.js, then npm install. And they are still giving free API key. Not many people know about it. So you can go and create their free API key and use one of their models for free. Okay. So if you're somebody who has been trying to use Olama to host models like Llama 7B and running into like high latency, I like, so one of the student whom I was interacting with, so she was trying Olama and Llama 7B, and to get one response, she was telling me it was taking her 10 minutes. And then when she switched to Gemini, again, Gemini API key is also available just like Claude. The 10 minutes became 10 seconds. So, uh, uh, yeah, better to go with these APIs rather than self-hosting those models. And one of the reason why they are able to offer so many things, these capabilities, is because they say that it is extended thinking, but actually what's really happening at the back is next token prediction only. Okay. And if you are somebody who is aware of chain of thought, how many of you are aware of chain of thought? COT. Okay. So multi-shot prompting, multi-shot prompt, zero-shot prompt. So what we do in zero-shot prompt, we don't give it any example. We just say this is the question, give the answer, right? But in multi-shot, we'll give it few examples. That this is the question, this is the answer, this is the question, this is the answer. Now, if I'm asking this is the question, then produce the output. Given that these were the responses for these two questions, so that's a two-shot prompt. In chain of thought is sort of a more evolved version of it, where we are also giving it some instructions, step-by-step instructions, that you need to follow these instructions or steps. So what you are doing is you are breaking the complex problem, or you are helping it break the complex problem into smaller sub problems. So just like how chain of thought breaks a complex problem into smaller sub problems, extended thinking also works in a similar way. Okay. And what they do is they sort of encapsulate whatever Claude is generating in a reasoning block by using these tags, and it is not really shown to the end user, but that's how the internal mechanics work. And whatever chunk is actually put in those think codes is actually sort of refined. Okay, and that's where their human braved self-critic principles that we are talking. So that really comes into the action and it refines the output. Okay, and what they, like, one of the differentiators when it comes to Claude is they build thinking tokens separately as compared to output tokens. Whereas if you really look at any other commercial language model providers, even during the thinking or analysis phase, whatever tokens are consumed, you get billed for everything. Okay, they have a different way of billing. Okay, they will bill you only for the output and input tokens that you give. So input is like the question that you asked or the document you uploaded, and output is the response that you are getting. So, but uh, I would still say, like, the costs which are involved in hosting and using these models, you will only learn about that when you really put something in production. Because as long as you are a student, you will probably keep using the free tier. But in real world use cases, like, companies are paying like $1 million just in a week. So that's where these companies are making money from. Uh, what with 4.6 version of models, you can also invoke adaptive thinking. Uh, so you can configure it in this way. And there are other things also there like max tokens, but and you can also give a instruction also. So design a CRDT for a distributed editor. So this is something that you can put on your own. It's sort of a prompt over the prompt. They have a system prompt. You are defining one more instruction on the top of it. Okay, and this is again an extension of extended thinking. Okay, and yeah, means if you want to sort of solve problems which involve quantitative information, for example, numerical data, then adaptive thinking helps. And they say that yeah, it also saves you on cost. Okay. Uh, So where all can you use these models? Means of course, okay, these models are latest and greatest, but where can you really use them? Okay, so recently the India AI summit was happening in Delhi, and like in one of the panel discussion, some of the panelists said that like just like we have a mobile phone, we have a mobile number, uh, and that's sort of a second identity of yourself, right? Like everything is linked to your mobile number, and that mobile number is linked to the Aadhaar, and sort of the whole system of digital products that you may be using revolve around your mobile number. So mobile number is like a extended identity of yours. Similarly, like it's sort of probably an imagination of some of these people, or it may become a reality. Agents are going to be an extension of us, and uh, in some way that is already happening. Like if you really look at people who are using ChatGPT subscription, paid subscriptions, they're talking to it, like they're talking to it all the time, and some of the people have actually uh, sort of got so much engrossed into it that they have started thinking that ChatGPT is sort of a companion to them. So that those things are actually already happening. May not be happening as much in like the global south as compared to the west, but it's already happening. So my like sort of my perspective or take on is that yeah, means it's good to have an agent which would know some of the things about you, so that things which you will actually get done, for example, booking a ticket or things like concierge services, if you can use the agent for doing those things, of course, it saves you time. Uh, so that's where the power of these language models could actually go in terms of creating agents or AI agents. Okay, and because they can do tool calling. So, for example, in terms of tool calling, it may be like pinging an API to sort of book a flight ticket or a train ticket, do a web search, fetch information. For example, you may be booking a flight, you may be going through the Google Flights data and comparing which is the cheapest flight without any stops. So that web search and then fetching that information can be done and by these agents who are built using these language models, and that can actually pull the information and do all the thinking that you might be doing. And in fact, if you use Claude Desktop for some of the automation, uh, it can take care of some of the things that you would do, like in terms of search, renaming files, okay, creating folders. So even controlling your own desktop is something these agents can do. Then, of course, code execution, even code creation, that's what we are going to do, the vibe coding part. And because their context window has increased to the extent that 200K is the context window, or even 1 million in case of some models, they can really store, they can really consume a lot of information. So what if you can also store the previous conversations that you had with the agent and use that to sort of enrich the conversations. So and for that you need memory as a plugin. So you can and the good part about these language models is they can store, they can consume anything as memory. Like it can be images, it can be unstructured data, it can be text data, numeric data, even JSON, every MD files. They can consume information which may lie across all these formats. So and you can keep dumping those to the memory, and then the language model will interpret and make use of it. Okay, I think text editor addition is something sort of like a very low hanging fruit. Uh, but I think memory and tool calling are the two big things, okay, which these agents can really do. So if you really think about having a parallel version of yourself, what you can do is you can sort of put all the information about yourself, the type of things that you like to do, and that will become part of its memory. And the moment you tell it, okay, I want to do this, or I want to say plan my itinerary to say go to Varanasi, then it will do all those things for you. And if you sort of expose it to APIs also or MCP servers, so API was the earlier way of interacting with applications. With language models, another thing which has come is MCP servers. So I'm going to cover that also. So how many of you are aware about MCP? Nobody in the room? MCP, Model Context Protocol. So all of you might be aware of APIs, right? You do a post request and it will return something, right? And but uh, when we talk about MCP, so uh, I would say it's just like another orchestration layer over the top of the APIs the way we know it. So when you have to say ping an API, what you would do, you would know that it will take the input in this format and it will give the output in this format. You have to know that, and you have to sort of adhere to that. Okay, you can't deviate from it. And suppose the way the API is written, that changes, its input and output format changes, you'll have to update your code. Right. So that sort of makes your code fragile in the sense that some human is required to go read the description or the documentation of that API provider every time the updates happen. Right. But if you are somebody who has created an agent, and you want to leverage that agent to interact with that API, how are you going to do that if the API documentation or the API input and output changes? So that's where like the real power of MCP comes into the picture. Uh, so it has two components, MCP server and MCP client. So MCP server is something which is actually closer to the API, and MCP client is the one who really discovers what is the expectation of that API, and it does that in event time by sending a request to the MCP server, which is exposing that API. So it will try to find out or discover what is uh, the expectation of this MCP server or the corresponding API, what all it can do, and what is the input it requires, in what format it will give the return the output. It will find out all those things from the MCP server. So you don't have to have the headache of figuring out every time when the documentation or the requirements of the API changes. So uh, uh, whenever you sort of ping like a query to the agent, the language model will trigger the orchestration file. That orchestration file will ping the client, MCP client, and then that client will go and discover what all MCP servers it has access to, and it will go and sort of ping in parallel to all those MCP servers and find out what all these servers are capable of doing. So it will get a list of all the MCP servers with their capabilities and their expectations in terms of input and output. Once it knows that, then the MCP client would try to sort of make a decision in terms of which uh, MCP server is to be called. So that becomes the deterministic part. That's where the logic comes into the picture. So the orchestration and the file or the orchestration logic along with MCP client will sort of try to figure out which MCP server is to be called given this is the query. Yeah. So so uh, uh, sir, I think I anticipated his question. So in some way I'll address. Okay. So uh, where was I? So yeah, so the MCP server would then will be decided by the MCP client itself based on the logic that is written in the orchestration, and because the orchestration logic is something that you as a human being would have written. Okay, so you have control over that, and that's where the deterministic nature of uh, the logic could actually be informed in the orchestration layer itself. Uh, Based on that logic, it will decide, okay, that this server is to be called, and the MCP client will call that server, give it the input in the required format, get the output, and then the output will be converted in a format which the language model can read. Okay, and then that input that comes from the that output that comes from the MCP server will be given to the language model in a readable format, and that will serve as the context for the language model to come up with a response. So again, now the language model's response is going to be determined by the context it got from the MCP server via the MCP client. Okay. So I would suggest that this is something uh, you all should try to implement at least once while you are here as a student, because the RAG agent that we'll implement will be sort of very simple or sort of basic in nature, but how do you actually use the like full power of these language models in interacting with a lot of APIs? That's something you can achieve using MCP. One more new thing that has come recently is Claude agent skills. Okay, so just like MCP is sort of a concept that was promoted by Anthropic. Similarly, this skills is also I would say like a concept that came from Anthropic. It was already there in some format. Okay, but they have given it a nice name, and giving a nice name sort of serves as an anchor point for a lot of people. So what it does is, so suppose you are solving a problem, and while solving that problem, you have a sort of set pattern that these are the 5 steps that you'll follow to solve that problem. Okay, but probably you may not know it in your subconscious. Inside your subconscious, you may be doing it every time, but you may not have put a pattern around it. Okay, or generalized framework around it. What this skills can really do is uh, the skill.md file, which contains the instructions. Uh, you can create it, or you can let the language model create it. So if you want to create it, you can put your instructions. If you don't want to create it, these language models have become capable in the sense that if you are solving a problem by interacting with Claude, something like this, okay, here, you're uploading a document, you're putting an API, you're doing all those things, okay, and you're getting output in return. If you ask it at the end of your session, once your problem is solved, that okay, create a skills file around it, okay, skills.md file around it, it will create that for you. And what it would do, you would have probably solved multiple problems which are similar in nature with Claude. It would generalize your approach, the instructions that you gave, and the outcomes that came. It will generalize all those things, and yeah, and it will create a instructions file which is also known as skill.md, and in that way your approach or your mental model will get captured in a place, and next time when you are doing a task which is similar to what this skill.md file is actually covering, uh, it will just fill the instructions from this file and execute the same task. I'll give an example. Suppose while booking a flight ticket, you may be sort of checking, okay, that I want a non-stop flight, I want a flight which departs early in the morning, I want a flight which is sort of uh, like one of the cheapest, okay, which also provides food. So it will remember all those things, that these are sort of the filters that you were putting while trying to find or shortlist the flights. It will, by looking at your conversational history, it will have observed all those patterns, And the next time, uh, and, and and using that, it can create a skill.md file. And the next time when you want to do the same task, instead of again going and chatting, giving those instructions, it can pull the information from the skill.md file and do all those tasks. So again, this adds a layer of determinism with respect to getting things done by these language models. So if you really look at the theme of how things are really evolving in the language model space, in some way or the other way, means they are trying to solve those problems which the language model based on its own internal architecture cannot address. Right. So because language model is just doing next token prediction and it is based on the probability. So adding all these things, either MCP server and MCP client, to get sort of more context to enrich your tool calling, or using these skills, okay, to solve problems in a set well-defined way. These are like the layers of determinism that all these companies are trying to add, because they know the language model can hallucinate, and that's a reality. We can't solve that. And uh, in the words of Yan Li Kun, who was there in Delhi few weeks back, so he is trying to solve this problem using the JPA series of models. So do check out like JPA framework. Wherever he goes, he only talks JPA. Okay, nowadays. So uh, and yeah, like Claude, and this is like the latest model, like in terms of from Anthropic, which is Claude 4.6. Uh, it has two identifiers, one with Opus and Sonnet. It does not have any Haiku version. So if you are looking at doing ultra fast things, then you'll have to go with Sonnet, okay, because Opus is like more advanced. And they have been able to harvest a lot of Indian data as well. And in fact, like I have somewhere read that they are sort of harvesting all the information by scanning all the books in the world and using that to train their model. So I think they got a hook on a lot of Indian books as well. And that's why all like most of the popular vernacular languages are now covered. So I'll sort of leave this slide for you to just read. Okay, means I already covered that you can use it to sort of do analysis of research papers. Uh, System design interviews are still there in like practice. DSA, at least I don't do it anymore. But because like DSA problem you can solve, like means it would, all these language models can solve, give you the steps very quickly. But like system design really requires some critical thinking, because you have to think about those three principles, which is sort of availability, resilience, and latency. So uh, there a lot of analytical thinking goes, and you have to understand the business problem. So the way you can use this is use that this is like you can use it as like an interviewer for yourself. You can give it a problem and then let it ask or generate questions for you, and then you can give the response and let it critique that. So that's a good way to sort of improve your system design interview prep skills. Of course, code review and debugging, writing test cases, in fact, even creating code like sort of prototypes, these things are good. Okay, that sort of brings me to the end of like the theory part. Okay, I'll sort of take a pause, okay, to see if there are any questions. Then we'll get over to the demo. Okay, how? Okay, I think we are doing well in terms of time, right? Like 1 hour I had reserved for theory, so I'm done with that. If there are questions, we still have 5-6 minutes, and we can even take a 5 minute break. Okay, and in the break also, if you some of you want, you can interact, uh, and then we'll go to the demo part. Okay, so let me know if there are any questions, and I can use a whiteboard also if you want. So please go ahead. Mhm. So okay, let me draw the architecture. So this is your MCP client. Okay. This is your MCP server. Okay. And here your APIs are there. Okay. And this is where your language model plus orchestration logic. So to people in the back, this is LLM, this is orchestration logic, MCP client, MCP server, and the APIs. Okay. So the MCP server is the one, MCP client is the one which sort of makes a handshake with the MCP server. Okay, and asks it that what are all the functionalities you have got. Okay, and it will do it not for just one server. It will do that for not all the MCP servers that are there. I'm calling it F2. This is S1. Then say S3, S4. Okay, so there will be say API 1 here, then API 2 here, API 3 here, and API 4 here. Okay, and uh, okay, so this can give an input. This can also give an input. Okay, and so when a query comes to the language model, okay, uh, so the language model, when the query comes, it goes to the orchestration logic. It will try to determine what is the nature of the query, what is that this person is trying to solve for. Then it is given to the MCP client. You can think of these as function calls. Okay. Now this MCP client, once it is awake, okay, that it knows, okay, that something is coming, some traffic is coming. Uh, it will sort of wake up and it will ping all these MCP servers. Okay, it will ping all these MCP servers and ask them, tell me what all you can do. Okay, and once it asks what all it can do, it will know what are all the functionalities it has got. Okay, now in a real business use case, what would happen is, suppose you say go to Make My Trip or Clear Trip, whatever, or Go Ebibo, and you start interacting with their chatbot or agent that okay, I want to book a ticket, okay, from say Delhi to Patna. Now, while it has to do that, okay, uh, it has to call the servers or APIs of all the airlines, right? Air India, okay, Indigo, Air Asia, right? So, so now, and for all these APIs, these companies would have written the logic in different way in terms of in what format they take the input, what format they give the output. That may be different, right? Because these are all different companies. You don't have a control on them. So, but they would have exposed this through the MCP server. Okay. So what they do is so they may change this. Okay. What the job of MCP server is, it will always discover what is the expectation or input output format of this API, and it will store that as an information. So you can call that meta information, and it has detected that, okay, asynchronous to this request, okay, and it has stored that. Otherwise, what would happen in if in real time it has to go and interact, then your latency will go up, right? So it has discovered all that. It does that and stores it. It refreshes that once in a while, okay, depending on what is the frequency you have set. And the MCP server for each of these APIs would know what all they are capable of doing, what all this API 1, 2, 3, 4 can do, and what is their input and output expectation. It already has stored all those things. So now so in terms of the business use case, when you are trying to sort of book a ticket, you don't have to ping all these APIs separately. right? And you don't have to discover in what format they require an input or out, and in what format they will return the output. All that thing is pre-stored. So it sort of saves you on latency. Okay, and uh, then the MCP client will find out from all these, pool this information together, and so then sort of give it to the logic. This logic, orchestration logic, will decide, okay, which server I have to call. Suppose the user has said, okay, book me an Indian Air, sort of Air India flight. Okay, so that's there, and then the Air India, this orchestration will determine that I need to call the MCP server which is related to Air India API. So it will call that server and get those things done. Okay, so uh, this language model does not need to have the overhead of figuring out everything during the inference time. So it saves on latency. It also, and like it sort of creates sort of a nice isolation that you don't have to update your logic here every time. Okay, if the logic of these APIs input output expectation is changing, you don't have to sort of figure that out and then update your logic or the way LLM responds. You don't have to do that every time. So the same prompt will work every time, even if this logic changes. Okay, even if these APIs change, right? So you get uh, sort of improvement in terms of uh, latency. Uh, then you can use an immutable logic. You don't have to update logic. You don't have to have the headache of updating the logic every time. And sort of good isolation. Okay, so even if you think of like from a security standpoint, okay, uh, if say it finds out that actually there is something malicious that is happening with this API, okay, or suppose this API itself is broken, okay, then the MCP server would know that, okay, that this is broken, so never to call this, okay, and it will just return the user that no, this Air India's API or MCP server is down, so we should not keep trying and pinging it again and again. Otherwise, what would happen? You will, if you are sort of, if the LLM is sort of getting this query that book an Air India flight, it will keep trying, it will keep calling again and again. But here, what would happen with the isolation that we get? It will know that this server is this API is actually down. So let's not try it again and again. Once it will try, it will know and it will just tell the user Air India server is down. Okay, so I can book that flight. Choose a different flight carrier, right? So these are the three things that this MCP server nicely provides you: latency, no need to update the logic again, and of course the isolation. So those are some of the business use cases. We are talking about authentication, right? Yeah. So this authentication, all those things will be part of the MCP client. It will have all that information. Yeah, of course, the API key that you'll have to provide, okay, so that the handshake can happen between server and this. Okay, so all that information you can store here on the client side, authentication. Okay, and so that the handshake between server and client can happen. Yeah, of course, if this API key changes, then this handshake will break, but that can happen anywhere, right? So the API key you'll have to update. Okay, so anything else? Okay, so let's take a 5 minute break and then we'll resume again. Okay, tea break. Okay, sure. funny people.